Friends of mathematics, welcome to our first video on marginality. This is section 4.5 and this is video A, like I said. And we should probably start out by getting some terms up on the board that we have costs, and this is the total money that we have to lay out to take care of business. We have revenue, and that's the total money that we get coming in. And the most important thing here is profit. And that's our net gains or losses. Now, the costs and the revenue and the profit, these are all going to be functions of Q quantity. So we could write this as C of Q and R of Q and P of Q. These are total costs, total revenues, and total profit for Q items produced. Where we start to talk is marginality. We're talking about how things change as we increase from one item to the next. And that's really a derivative item. We're going to define the marginal cost, MC, as the derivative of C with respect to Q. And where this comes from is this is how the costs increase as we increase from one item to the next. So if I'm making, say, 100 items, if I wanted the marginal cost of 100, this would be, we could say, how much did the cost increase as I went from 99 items to 100 items? So we could say that this is C prime of 100, but that's approximately going to be equal to what? Well, it's going to be the cost of 100. That's the total cost of making 100 items minus the total cost of making 99 items. And because for the most part, quantities are going to only be these integer increments, that's a pretty good way of thinking about our marginal cost. Let's look at what this means in terms of profit, because profit is king, yes? If my revenues are very, very high, it doesn't really matter unless my costs are less than my revenues. So let's take a look at our profit relationship, and certainly profit is equal to the revenue minus the cost, yes? And what I might want to do is let's maximize profit. How am I going to make that happen? Well, let's take the derivative, let's set it equal to 0. And so I could say that P prime of Q is equal to, and now let's use our language with marginal, not the derivative of C. So this is going to be the marginal revenue minus the marginal cost, yes? Now, we took our derivative. How do I find my critical point? Well, I'm going to set it equal to 0. And then I can solve, and we see something fantastic here, that the max profit occurs, or the min profit occurs, because that can happen too, when the marginal cost is equal to the marginal revenue. We have a critical point for profit. Let's start out with some cost function and some revenue function, and let's look at those graphs and think about what the profits might be. So I'm going to have a Q axis, and we'll have some dollars axis here. And let's have the revenue have just this linear function. And the whole idea here of this is I'm going to be selling each item for a fixed amount, and so we're going to have a linear function. Now, we should probably say that, Q is some quantity. These are probably going to be integers, and this is going to be a discrete function, not a continuous one, but whatever. We're just thinking right now. And let's suppose our costs do something like this. How about our costs go like that? And then our costs go like here. And then our costs maybe do something like this. Now, costs can change. Like right now, we would call this point right here the fixed costs. Because I'm going to have to pay something even though I haven't produced any items. But let's start to explore. And our first questions are, where does C of Q equal R of Q? And I think we've got some pretty good ideas right here. We have these two places, yes? Now, what does this mean? We'll call this x1 and x2. These are called break-even points. Now, we should probably be able to ascertain why, when the cost and the revenues are equal to each other, our profits are going to be zero. And keep in mind, once again, that the profit as a function of Q is equal to the revenue, the money's coming in, minus the costs going out. Yeah? Not a great stretch of the imagination. So this is a great question. There's the first one. And now the second one, and the real important one here is, where are profits maximized? Now, if I look at this graph, I'm really thinking about some amount of money, yes? And I want the money for R of Q to be minus C of Q. I want to be largest. And so this is a vertical distance on my graph. At x1 and x2, that vertical distance is 0. Profits are 0. In this region, from quantity equals 0 to x1, the cost equation is above the revenue equation. And so that means here I'm going to have losses, yes? Here I'm losing money. Also, over here, that's going to be a loss because the costs are greater than the revenue. I think it's going to be somewhere in that spot. And I'm going to call this just happy face, yes? Because that's where the vertical distance between the cost and the revenue is maximized. Okay, now, do you remember our previous discussion? If we looked at this as calculus students and where the profits are going to be maximized, we would take the derivative, we would set it equal to 0, and we would solve. And we wound up with what? That the marginal cost equals the marginal revenue when this occurs. So what does that mean in the context of this problem? Well, all it means is that we're going to have slopes that are equal to each other. And so let's just check. If I look right here and I go Take a look at this. The revenue of Q, MC, or MR, is going to be a constant, yes? And the slope of C at that exact same point was exactly the same, yeah? Now, let's do another example, taking this marginal revenue and this marginal cost idea out for a spin, just over here with a quick function. And I'm going to be kind to us. I'm going to have the revenue do something like this. And I'm going to have the cost do something like this. And the reason I would refer to this as kind is it doesn't always happen like this, that the revenue and the costs diverge so greatly. So here we certainly had our break even. This is the region that we want to avoid, where the costs are greater than the revenues, but anything over here is good. And suppose you and I are making this number of items. I'm going to call it Q naught. And the question is, should we make more? Now, we don't imagine that we can see the graph here, but if I was to look at the slopes right here, MR evaluated at Q naught versus MC evaluated at Q naught, which one of these is bigger? Well, certainly MR is greater than MC at this value. The slope here is bigger than the slope there. And what that tells me is that the revenues are growing faster than the costs are. And so we should continue to make more items. If I was to maybe make this thing have a downturn here, and let's say we kept producing until this number of items, QX, should I continue to make items here? And now the marginal revenue is less than the marginal cost, and we should cease and desist, yes? And in fact, the maximum value, the place where we should have stopped, where this was maximized, was when the slope here was exactly the same as the slope there.